You know how your phone just knows what time it is instantly, no matter where you land in the world? It feels like magic, right? Well, it's not magic, and getting that seemingly simple thing right is actually one of the biggest, most hidden challenges in all of software. So today, we're going to pull back the curtain on the secret world of managing time zones. Okay, let me ask you this. Have you ever tried to set up a meeting with people in like 3 different countries? It's a nightmare, right? You say, hey, let's do 3 p.m., and immediately it's chaos. Wait, your 3 p.m. or my 3 p.m.? Your afternoon is their middle of the night in Tokyo and their crack of dawn in California. It's all about context and it's a mess. All right, so now take that simple human confusion and just imagine multiplying it by a million. That's what software deals with every single second. For a computer which needs absolute, perfect precision, local time isn't just a headache. It's a complete nightmare that can literally break everything. So let's dive into exactly why that is. Before we get too deep, we need to understand how software talks to other software. And the best way to think about it is with this analogy, an API. It's like a digital waiter. Seriously, your app, say on your phone, wants something. It could be data or it wants to do something. So it gives its order to the API. The API then goes off to the kitchen, the server, gets exactly what was ordered, and brings it right back. You, or your app, don't need to know how the kitchen works. You just need to know how to order from the waiter. So this is exactly where our poor digital waiter gets a massive, massive headache. Imagine your app tells the waiter, hey, record this event for 3 p.m. The waiter just stands there confused. 3 p.m. Where? London? New York? Tokyo? And what about the absolute chaos of daylight saving time? You know, the thing that changes the rules twice a year, but only for some places? Yeah. For a computer that craves perfect, unambiguous consistency, local time is just pure, unadulterated chaos.
Okay, so how on earth do you solve a mess this big? Well, the entire tech world realized they needed a universal solution, a system. And it really came down to 2 key things. First, they needed a single master clock, one time to rule them all for the entire planet. And second, they needed a common language, a way to write that time down so that any computer anywhere in the world could understand it, no questions asked.
And that first piece of the puzzle? It's called Coordinated Universal Time, or UTC. You've probably seen this before. Think of UTC as the absolute gold standard. It's the 0 point for time for the whole world. A great way to think about it is like the prime meridian for maps, but for time. It's that one single, unchanging reference point that everything else is measured from. But, you know, having that master clock isn't quite enough on its own. You also need a way to write it down that leaves 0 room for confusion. And that's where the second piece comes in, a standard called ISO 8601. It sounds technical, but all it is a strict set of rules for writing dates and times so that any machine on the planet can read it perfectly every single time. So this is what that universal language actually looks like. When a computer sees this string of text, there is absolutely 0 confusion. You've got the date, then that T in the middle just separates the date from the time, and then you have the time. Simple enough, right? But the real magic, the secret sauce, is that little Z at the very end. That Z stands for Zulu time, which is just another name for UTC. It's a signal to the computer that says, hey, this isn't just any time. This is the time, the one universal point of truth. All right, so when developers are actually building things and talking to those digital waiters, those APIs, they're really dealing with time in 2 different directions. First, there's receiving time from an API. That's usually the easy part, but then there's sending time to an API. And that, my friends, is where things can get a little tricky. Let's break them both down.
Okay, first up, let's talk about the easy one, getting time from an API. Any well-designed API out there, like the one GitHub uses, for example, follows one simple golden rule. It always gives you the universal truth.
And the process here is it's beautiful. It's so simple and elegant. The API sends you a timestamp, and it's always in pure UTC written in that universal ISO 8601 format. Then your app, the thing running on your phone or computer, takes that perfect universal time and does one simple job.
It converts it to your local time zone right before it shows it to you. That's it. The API gives you the fact, and the app adds the local context.
All right, now let's flip the script. This is the trickier part. What happens when your app needs to tell the API, hey, something happened at this specific time? Think about scheduling a social media post, or booking a flight, or logging when an event happened. You have to be incredibly clear with that digital waiter about exactly when you're talking about. So developers actually have a few different tools in their toolbox for this. The absolute best way, the gold standard, is option A, be totally explicit. You send the full timestamp with the time zone offset. You're basically telling the API, look, it was exactly this time and it happened in this specific part of the world. No room for guessing. Option B is kind of like saying, okay, tell me the time right now, but pretend you're in Amsterdam. It's still pretty precise. Then you have C and D, which are more like fallbacks. The API can try to make its best guess based on what it knows about the user, or if all else fails and it has no information, it just defaults to UTC, which is always the safest bet. So you might be asking, why have so many options? Well, it's all about flexibility. It's about giving developers the right tool for the right job. Sometimes you need that perfect, pinpoint precision for, say, a financial transaction. But other times, you just need to capture the idea of now in a specific city. These different options give developers the power to choose the level of precision they need. Okay, so we've talked about all this complexity. How do the pros actually handle this stuff and get it right every single time? Well, it really boils down to a few golden rules. These are like the foundation for building any solid global software.
It really comes down to just 3 things. Rule number 1, always work in UTC on the inside. All your code, all your databases, everything should think and breathe in universal time. The only time you should ever think about local time is at the very, very last moment, right before you display it to a person. Rule number 2, be explicit. When you send time to an API, don't be vague. Tell it exactly what you mean. And rule number 3, test, test, test. You absolutely have to check how your code behaves across different time zones, and especially during those chaotic daylight saving time changes, that's where the nasty bugs hide.
Look, this stuff isn't just some nerdy technical detail, it's the invisible engine that makes our entire connected world run smoothly. So the next time you book a flight across the world or get a notification that shows up at exactly the right local time, you'll know the secret behind it. And that leaves us with one last, kind of scary thought. What breaks when apps get this wrong? I mean, really think about it. Failed bank transactions, missed flights, critical medical appointments gone wrong, all because a computer somewhere didn't know what time it really was.